Calculate the cell potential at 25 degrees Celsius based upon the overall reaction. 3Cu2 plus 2Al yields 3Cu plus 2Al3 plus. So it gives us the standard reaction potentials here and the values, and it wants us to find the overall cell potential. So you're going to use this formula, which is the cell potential of the cell equals that of the cathode minus that of the anode. So your first step is going to want to identify what's being reduced and what's being oxidized. So first we're going to do the oxidation numbers. So for this one, I see that it's +2. For this one, there's nothing here, so that's a 0. For this one, it's also going to be 0. And for this, it's going to be +3. So for this, I always go with Leo the lion says grr. Childish, but it works. So we see that this one's going from +2 to 0. So let's just which means that it's gaining electrons because it's getting more negative. So we're going to label this as reduction because it's gain electrons reduce or reduction. And then so for this one, we can see that we're going from 0 to +3, which means we're getting more positive, so we're losing electrons. So that's losing electrons oxidation. So now for over down here for the reaction potentials, what we do know for sure is that reduction happens at the cathode. So we look at which one's being reduced, which would be the copper right here. So for this one, we label it as cathode. And obviously because that's cathode, the other one's going to be our anode. Then we go back down here to this formula, and we see that the cell potential of the cell will equal the cathode, which would be positive 0.34 volts. Minus negative 1.66 volts. Now if we do that, two negatives we know make a positive, so it's really going to be 0.34 plus 1.66, which is going to give us 2.00 volts, and that is our answer.